So I wanted to, before I go on to number 4, wanted to talk a little bit more about 1, 2, and 3 in case you're feeling overwhelmed or frustrated. I think last year what I suggested that people do is like on a problem, let's just look at number 1, is I think I told everyone to just simply draw the circle, and whatever you find for theta, know that that goes here. This is 0.6435, 0.6435, 0.6435, 0.6435. And then you know that this is 0 plus 0.6435. This is pi minus 0.6435. This is pi plus, and this is 2 pi minus. So for instance here, this is 0.9828. And this is 0.9828. And so is this, and so is this. So then here, you know that this is 0.6435. I'm sorry, I meant to come down here to number 3. Here, when we get theta is negative 0.2527, all that matters is that this is 0.2527, this angle right here. All of them are 0.2527. And this is 0 plus, this is 2 pi minus, this is also 0.2527, and this is 0.2527. It's the reference angle that matters, and this is going to be pi plus 0.2527, which is where I got that from, and this is 2 pi minus, which is where I got that from. Now I believe when I put this into the calculator, I actually typed in 2 pi rather than 6.28, and that's where I got this from, and here I actually typed in pi. I don't know if that helps at all. I'll try to show that when I solve number 4. Alright, so for number 4, we're going to add 3 to both sides, and we get that the sine of theta equals 7. Well, I can already tell that this is not going to have an answer, because remember, the biggest that sine ever is 1. So we get that theta is the inverse sine of 7, which means it would have to be, because it's positive, it would have to be in quadrants 1 and 2. However, when I put this into my calculator, inverse sine of 7, I get an error. That means that there is no solution. And it makes sense because remember, on our sine graph, when we had a sine graph, the highest it was 1, and the lowest it was negative 1. So it can't ever actually be 7. All right, let's go to these last 2 on this page. So just want to show you, we've done all the different types of equations that we solved on that paper earlier. Where did I put that? That very first page, when we looked at the different types of equations. We've done basic ones. We've done where you have to do maybe 2 steps. Here we did where you have to take square roots. Letter D, we did ones where you have to factor. That's what we're going to look at now, where you have to factor in order to solve the equation. So I can tell that, obviously this is a quadratic because I've got cosine squared. And I need to set this equal to 0 in order to solve a quadratic. It always needs to be set equal to 0. So I'm going to subtract 1 from each side. And I get 2 times the cosine squared of theta plus cosine of theta minus 1 equals 0. Now, for a lot of people, having the words cosine squared and cosine here they just don't understand how this could be factored. So what I'm going to suggest is that we do a little bit of substitution. And let's, instead of writing cosine, let's let x equal cosine of theta. And rewrite this as 2x squared plus x minus 1 equals 0. So let's write down a series of steps. The first thing we did was we set equal to 0. The second thing we did was we let x equal cosine of theta or x equals sine of theta, just depending on the problem. Like in number 2, it's going to be sine. All right. Our third step now is to factor. So when I factor this, I know that it's going to be a binomial times a binomial. And whenever you're factoring, I'm hoping that you know how to factor this at this point. You should have learned basic factoring like this. The first term here is going to be determined by these two right here. The only way to get 2 is 2 and 1. It's the only way. And the only way to get x squared is x and x. When I multiply using FOIL, I'd have 2x squared. And then the other term you have to look at is the last term. So you look at the first term and you look at the last term. Well, the only way to get 1 is 1 and 1. But you need it to be a negative 1. Now this is going to matter. That means one of these is going to be positive and one is going to be negative. So what you have to figure out is, well, which is which? Well, try it one way, and if it doesn't work, then switch it. Only way to get a negative is a positive and a negative. Let's see if this works. So for my middle term, in FOIL you do your outers and your inners. Negative 2x and positive 1x. Negative 2x and positive 1x gives me negative x. I don't want negative x. I want positive x. So let's try switching these to negative and positive. Let's see if that works. 2x times 1 is positive 2x, and negative 1 times 1x is negative 1x. 2 minus 1 is positive x. That's what I want. And then I know that I have factored correctly. My fourth step is to put sine or cosine back in. You can't forget this step. So this becomes 2 cosine of theta minus 1, and this becomes cosine of theta plus 1 equals 0. All right, I'm going to keep going. I'm going to move this number 2 down to here and rewrite it just because I feel like it's in the way right now where it is. Just erase that. That way we can just keep working. There we go. All right, so put them back in, and then my next step, remember what we do when we factor, one of these has to be 0. The only way to get a product of 0 is if either this equals 0 or this equals 0. So set each factor equal to 0. So 2 times the cosine of theta minus 1 equals 0. And cosine of theta plus 1 equals 0. And my last step is to solve each factor, which brings us back to the very basic equations that we did at the beginning. Add 1 to each side. 2 times the cosine of theta equals 1. Divide both by 2, and I get cosine of theta is 1/2. So theta is the inverse cosine of a half. But remember, I took the inverse here. I did this. So it's everything on the unit circle, like it says up here, 0 to 2 pi. So I go to my unit circle, and I'm looking for the cosine to be a half, the x-coordinate to be a half. All right, let's see. Now there, right here, so it's got to be one of my blues. So it's a positive 1/2 right here. It's also positive half right here, and I only want it to be positive 1/2. So pi over 3 and 5 pi over 3. So theta equals pi over 3 and 5 pi over 3. Those are two of my solutions. Now I have to come to this factor, and I need to solve. Subtract 1, cosine of theta equals -1. Theta equals the inverse cosine of -1. And remember, since I took the inverse, I need to give all possible solutions. So I'm looking for an x-coordinate of -1. So I go to my unit circle. X-coordinate -1 happens right here at pi. So theta equals pi. So I have 3 total solutions for this: pi over 3, 5 pi over 3, and pi. All right, let's try number 2. First thing I need to do is set it equal to 0. So I'm going to subtract this and subtract this from both sides. So I get minus sine of theta minus 1 equals 0, because I would have subtracted this here as well. Second step is let x equal cosine of theta or sine of theta. This time it's going to be sine of theta. So 2x squared minus x minus 1 equals 0. Then I factor. Only way to get 2x squared is 2x and x. Only way to get 1 is 1 and 1, but I need it to be negative. So I'm going to try plus and then minus, and I'm going to check my middle terms. My middle terms are from my outers and my inners. 2x times -1 is -2x. 1 times x is plus 1x, and I get -1x. That's what I wanted. So these are my factors. Put sine or cosine back in. You've got to remember to do that. 2 times the sine of theta plus 1 times the sine of theta minus 1. My next step says set each factor equal to 0. So I'm going to come over here to do that. 2 times the sine of theta plus 1 equals 0. And sine of theta minus 1 equals 0. Subtract 1. Sine of theta equals -1. I'm sorry, 2 sine of theta equals -1. Divide by 2. Sine of theta equals -1/2. So theta is the inverse sine of -1/2. So I go to my unit circle, and I'm looking for a y-coordinate of -1/2. Y-coordinate right here is -1/2, and over here is -1/2. That's 7 pi over 6 and 11 pi over 6. So theta equals 11 pi over 6 and 7 pi over 6. And for this one, I add 1 to both sides. sine of theta is 1, so theta is the inverse sine of